Welcome to our comprehensive guide on piping engineering design. In the next 10 minutes, we'll explore the fascinating world of industrial piping systems and the crucial role they play in various industries. From oil refineries to power plants, piping systems are the lifelines that keep our modern world running. What is piping engineering design? Piping engineering design is the process of planning, designing, and documenting piping systems for industrial applications. It involves creating detailed plans for the layout, sizing, and specification of pipes, valves, fittings, and other components. These systems are used to transport fluids, gases, and sometimes solids across various industrial facilities. The primary goal is to ensure safe, efficient, and cost-effective fluid transportation while meeting all regulatory requirements and industry standards. Key aspects of piping engineering design: pipe routing. This involves determining the most efficient and safe path for pipes within a facility. Pipe sizing. Engineers calculate the appropriate diameter of pipes based on flow rates, pressure, and other factors. Material selection. Choosing the right materials for pipes and components based on the fluid being transported and environmental conditions. Stress analysis. Evaluating the effects of pressure, temperature, and external forces on the piping system. Support design. Creating and placing supports to handle the weight and movement of pipes. Tools and software in piping engineering design. Modern piping engineers rely on various software tools to streamline their work. AutoCAD software, for creating detailed 2D and 3D models of piping systems. PDMS Plant Design Management System is widely used in industrial piping design for 3D modeling, clash detection, and generating accurate isometrics. Thousands of engineering, procurement, and construction EPC companies, particularly in oil and gas, petrochemical, and power industries. It remains a popular choice due to its scalability and compatibility with various industrial standards. Aviva Everything 3D is extensively used by global EPC firms for advanced 3D modeling and design in industrial piping projects. SmartPlant 3D is widely adopted by numerous EPC companies for efficient 3D modeling and management of industrial piping and plant design projects. Pipe stress analysis. Software to simulate and analyze stress on piping systems. Fluid flow simulation software for modeling fluid behavior within pipes. Piping codes and standards. Piping engineering design must adhere to various codes and standards, including ASME B31, a series of codes for pressure piping API standards, developed by the American Petroleum Institute. These codes ensure safety, reliability, and consistency across different projects and industries. The piping engineering design process. The typical process involves several stages: conceptual design, developing initial ideas and layouts; detailed design, creating comprehensive plans and specifications; 3D modeling, building detailed digital models of the system; analysis and optimization, performing stress analysis and optimizing the design; documentation, preparing detailed drawings and specifications; review and approval, getting the design checked and approved by relevant authorities. Challenges in piping engineering. Design piping engineers face various challenges, including space constraints in complex facilities, balancing safety, efficiency, and cost; ensuring compatibility with existing systems, meeting stringent regulatory requirements. Piping engineering design is a critical field that combines technical knowledge, creativity, and precision. As we've seen, it involves various aspects from pipe routing to stress analysis, all governed by strict codes and standards. Whether you're a student, professional, or simply curious about industrial processes, understanding piping engineering design gives you valuable insight into the complex systems that power our world. Thanks for watching our guide to piping engineering design. If you found this video helpful, please like, share, and subscribe, and click the bell icon for more engineering content. Until next time, keep learning and stay curious.